Hello friends, this video on electromagnetic induction part 20 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 19 before going ahead with part 20. We will now study a very important application of electromagnetic induction, and that is AC generator. I would have mentioned about AC generator while I was talking about the different methods of producing EMF, right? That time I told you that by varying the angle between the magnetic field and the area vector, we can also change the magnetic flux. So AC generator was an example of that. So now we will see what basically an AC generator is. Well, it is a device that converts mechanical energy into electrical energy. You remember in our previous lesson, we learnt about electric motor, right? In one of our previous lessons. So what was electric motor? Electric motor was a device which converted electrical energy into mechanical energy, right? So AC generator is just the reverse of electric motor. Here, mechanical energy will get converted into electrical energy. The principle behind an AC generator is current is induced in a loop through a change in its orientation or a change in its effective area, right? As I mentioned before also, how is a current induced? Because of the induced EMF. And when an induced EMF is produced, either by change in theta, because we know that phi is equal to dA cos theta. So we can change the flux either by changing magnetic field or area or the orientation between them. So this AC generator is based on these two factors, area and the orientation. So we will see how it works in the next few slides. So before that, we will talk about the construction of an AC generator. What are the different parts, or what are the basic elements that make an AC generator? It consists of two pole pieces, north and south of a magnet, so that we can have a uniform magnetic field. So we have a uniform magnetic field somewhere here in this way. Then we have a coil. A coil somewhat rectangular in shape, as you can see here. This coil is also known as armature. This coil is also termed as armature. Right? Now this coil is kind of, it is like connected to slip rings. These are the two rings which are called slip rings, and attached to them are carbon brushes. So these are the arrangements. This is how it is arranged. You have a rectangular coil which is attached, towards its handle, there are a pair of slip rings which are in turn attached to carbon brushes. Now there is an axis of rotation for this rectangular coil. This rectangular coil is capable of rotation, and it rotates about an axis which is perpendicular to the magnetic field. So this is the axis of rotation, and it is known as the axle, right? So these are the basic parts of an AC generator. So the basic parts are a magnetic field present. There is a rectangular coil. There is an axis of rotation which is perpendicular to the magnetic field. So now how will the coil rotate? The coil will rotate about this axis, somewhat like this. So now let us look at the working of the AC generator. When you look at the AC generator, it would rotate somewhat like this. So this will give you a vague idea of how it rotates. Somewhat like this, right? So now let us talk about its working. Let us suppose at initial time t is equal to 0. That means when it just starts. At that time, what is the value of theta? Theta is equal to 0. Now what is theta? You remember I spoke about theta as the angle between the magnetic field and the area vector. That means the angle between, what is theta? Theta is the angle between the magnetic field B and the area vector. That means it is the angle between this B and the normal to the area. So here in this case, this is, let us suppose if you draw a normal to the area, so the angle which it makes with the magnetic field, that is your theta. So at initial t, when the time starts, let us suppose theta is equal to 0, because at that time the the rectangular coil would be in a position where your area vector makes angle theta with the magnetic field. So in that case, what would be your magnetic flux? That will be equal to BA, because cos 0 is 1. Now let us suppose that the coil rotates with angular velocity omega, right? So what will happen after some time t? So after time t, theta will be equal to, what is omega? Omega is angular velocity, so we define omega as d theta by dt, right? This is how omega is defined. So after time t, theta will be equal to omega t, right? So that means this coil, for this coil, theta is changing, that is angular displacement is changing. So we can say that because of this change, the magnetic flux is changing. So we can say that the flux at time t will be equal to BA cos theta. So we can write it as BA cos omega t. So that means, therefore, change in flux occurs, because as I already mentioned, if theta changes, that is if the orientation between the magnetic field and the area vector changes, then there is a change in flux. Now since there is a change in flux, now according to Faraday-Lenz law, there is an induced EMF in the coil, right? So this induced EMF is given by minus d phi by dt. Right? Now, if we say that this coil has some n number of turns, then we can write it as minus n d phi by dt. So this becomes minus n d by dt of BA cos omega t. So this becomes equal to n BA omega sin omega t. So this becomes the value for induced EMF. Now looking at this, we can see that this sin omega t is a periodic function. It is a sinusoidal function. So this sin omega t will vary from minus 1 to plus 1. So sin omega t, it is a sine function. So this sin omega t will vary from minus 1 to plus 1. Therefore, we can say that minimum value of E will be equal to minus NBA omega. This will be minimum E. And what would be the maximum value of E? That will be equal to NBA omega. So we can say that the value of E varies from minus NBA omega to plus NBA omega. Therefore, we can write E is equal to E naught sin omega t. Right? What is E naught? E naught is nothing but, E naught represents this value, NBA omega. We represent NBA omega as E naught. So we see that the induced EMF produced would be a sine function. So we can represent the induced EMF as a sine function. So when omega t is equal to 0, it is 0. When omega t is equal to 90, it is E naught. So if you take the EMF along y-axis and if you take omega t along x-axis, so when omega t is 0, EMF is 0. When omega t is 90, EMF is E naught. When omega t is 180, EMF is again 0. When omega t is 270, it is minus E naught, and so on. So therefore, we can say that the EMF which will get induced will change periodically. Therefore, we can say that the direction of induced current will also change periodically. Therefore, induced current will change periodically. Now, since this current changes periodically, so we call this current as alternating current. So this is known as alternating current. So now, what is this omega? Omega is the angular velocity, right? So what did we see here? What was our generator? The purpose of generator was to convert mechanical energy into electrical energy. So where was the mechanical energy? Since this rod is getting rotated, who is rotating this rod? the rod is getting rotated by some external means. So that means there is something which is rotating the rod. So that rotation of the rod is nothing but mechanical energy. Now this external means by which the rod is getting rotated, that external means can be anything. There are, depending upon what is that external mean which rotates the rod, we have different types of generator. Like we have nuclear generator, we have hydroelectric generator, we have power generator. So I will brief about them after a few slides, right? So that means when I talk about a generator, it basically changes the mechanical energy. That means when you are rotating the rod, that mechanical energy is finally getting converted into an induced EMF. Now an induced EMF is produced because of that. As a result of that induced EMF, there is an induced current which is produced, and from this calculation we see that the induced EMF is a sine function. That means it changes periodically. It changes between one maximum and one minimum value. Therefore, the corresponding current will also vary between a maximum and minimum value. That is an alternating current. So, with the help of this instrument, you are able to convert mechanical energy into alternating current, that is electrical energy. So, this is how an AC generator works. So, you understood the significance of the orientation, how the variation in the orientation between magnetic field and area vector be of so much useful purpose. Now, this diagram tells you the orientation at each stage and the corresponding EMF at that stage. So, when I consider stage 1, at stage 1, if you look at it, this is how the coil is. This is the initial stage of the coil. So, at this point, this is the angle of this is the magnetic field. Now, what is the normal to the area vector? This is a normal. Can be a normal to the area vector, which is at 90 degree. The normal to the area vector is in this direction, right? Because this is how the area vector is. So this angle is 0 degree. So right now theta is equal to 0 degree. So for theta equal to 0, your induced EMF is what? Induced EMF E is equal to E naught sine omega t. So if omega t is 0, that is equal to E naught sine theta. So if theta is 0, your E is 0. Now in the next stage, this coil gets rotated by 90 degree. So once you rotate it by 90 degree, it will be in this position. That means your theta is equal to 90 degree, because this is the angle of B and this is the normal to the area vector. So this is 90 degree, right? Now the coil again gets rotated. So now your angle becomes, this is the angle for B, and now the normal to this is this one. That means this angle is 180 degree. So it is again 0. Corresponding to 180, it is again 0. In this case again, this is the angle of B, and now it gets rotated by 270 degree. Right? So in this case, the value is -1. So it goes here. Again it gets rotated. So that means now it is rotated by 360 degree. Right? So you see, for each orientation you have a different value and it is a sine function. So that is how we get an alternating current as an output from an AC generator. That is why it is called alternating current generator, because the output it gives is an alternating current which changes itself periodically. Now, as I mentioned before, depending upon the external means by which the rectangular coil in the generator is rotated, there are different categories of generator, or there are different names given to AC generators. There is hydroelectric generator, there is another one called thermal generator, there is another one called power generator. What do I mean by hydroelectric generator? When I talk of a hydroelectric generator, it means that hydroelectric power, that is the power due to the flowing water, that is used to move the rectangular coil. Right? So where you saw the handle of the coil, right? So there you put a lot of force using flowing water, and that flowing water causes it to rotate. So that is why it is called hydroelectric generator. Similarly, when thermal power is used to rotate the generator, they are called thermal generators, and so on. So and so forth. You get different types of generator depending upon the external means which is used to rotate the rectangular coil in the generator. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.